Recitation problem 4. The drawing shows a force vector that has a magnitude of 475 newtons. This is the one in blue here, which is presented in a three-dimensional system. It's pointing somewhere between the x-axis and the y-axis and also the z-axis. The question is to find the x, y, z components. This is not a simple two-dimensional question. So we need to really be careful and have that three-dimensional imagination. Alright, we can easily solve for the z component, but because they said solve for the x, y, and z components in that order, I'm going to try to do so. Okay, where is the x component first? Let's find that one. Now the f vector is somewhere between the x, y, and z. Now, to get to the x component, what you need to do first, you take this vector f in blue and project it down on the plane x, y, this plane here. If you project it down on this plane, you obtain the following vector in magenta. I'm going to call that vector A. One more time, the vector A is the vector f projected on the plane x, y. Which angle can we use to figure out the size of vector A? Notice that the 54 is the angle that is made with the z-axis. Therefore, the vector that f makes with the A vector is 90 minus 54. This one, which equals 36. I could use the 54 or the 36 to find out the vector A. Notice that the vector A makes an angle of 90 degree with this projection here, this dashed line. So the 90-degree angle is right here. You really need to have that three-dimensional imagination. Using this right triangle, let me just make sure you know which one. The one made with the blue vector f, this dashed line projecting down on the plane xy, and the vector a, which is right here at the projection point. Okay, let's try to solve for that one. I'm going to use the angle 36. I could use the 54 if I want to. The 36 may be easier for you. Cosine 36 is going to equal adjacent, which is the vector A, divided by the hypotenuse, which is the vector f. Alright, cross multiply, you can find the vector A to equal f cosine 36. I can also use the 54, but if I use the 54, the result will be A equals f sine 54. The answer will be exactly the same. Now, we know the f, it's 475. Put those together, we solve for the A to equal, A equals 384 newtons. This vector A is now very useful for us to solve for the x component and the y component for the vector f. This is the x component for f. A right angle is right here. This is the 90-degree angle. Now, if we use the 33-degree angle, we can easily solve for the fx. Cosine 33 equals adjacent, which is fx, divided by the hypotenuse, which is the vector a that we just solved for. Therefore, the f of x is going to equal a cosine 33. Put together that information, you solve for fx. Notice that the a is 384 equals 322 newtons. This is the first component. The y component is this one along this dashed line parallel to the y, or you can also present it along the y-axis itself. I'm going to try to present it here for simplicity. This is the Fy. It's not too complicated to visualize. If I put it on the y-axis, it may be a little bit difficult for you to see. Now, if you look at the Fy, is the component opposite to the 33 degrees. So you can easily solve for it by using the trig function sine. The sine 33 equals f of y opposite divided by the hypotenuse, which is a. Isolate the f of y, you get a sine 33. Put together that information, you find f of y to equal 209 newtons. The z component, and that's the easier component to solve for really, is the component along this dashed line in magenta. It could also be represented along the z-axis straight up, but I'm going to keep it here so we can easily visualize it. The right angle is right here, made between the z component and the a vector. Notice that the fz component is opposite to the 36 degree. Therefore, sine 36 equals opposite, which is the fz, divided by the hypotenuse, which is the vector f. Isolating the fz, you're going to get f sine 36. Notice that you could use the vector a if you want to, but in that case what you do, tangent of 36 equal opposite fz divided by a. You would get exactly the same answer. Now I'm going to continue what I have done here. So fz is going to equal, after we substitute the f by its value of 475, we get 279 newtons. This is not a straightforward question because of its nature, three-dimensional, but it's a good practice and it will give you a good idea how to handle components in general.